All right, also, first off, we'll start with 9.3, and that deals with exponential functions. And exponential functions will be functions like f of x equals a to the x, where the variable is now the exponent. Okay. So the variable is the exponent. So a few things about exponential graphs. If the number being raised to the exponent, if it's greater than 1, then the graph is going to go uphill to the right. If the a is less than 1, such as a fraction, then that graph will sort of be the opposite, and it's going to come down from left to right. So fractions will sort of decrease left to right. If the a is greater than 1, then it's going to increase left to right. These exponential graphs are what y'all seen on COVID. Y'all remember how quick that COVID spread and multiplied? So that's what these graphs are representing here, okay? So a few things about these graphs. One thing about exponential graphs, they all pass through the point 0, 1. So that'd be these points where I got it on that y-axis crossing right there, okay? The reason they all pass through the point 0, 1, any number raised to an exponent of 0, remember, any number to the 0 power equals 1. So if my variable is x and is 0, then the y value will be 1, okay? They're continuous. That means they continuously flow without any breaks in the graph. And then the domain is all real numbers. So that means they keep cruising to the right and they keep coming in from the left, okay? As my x's go from -infinity to infinity, and it will be a continuous graph. Now, before we actually look at the graphs, they want y'all to play with what we call Euler's number. And Euler's number is that fancy little e. It's sort of it's a constant like pi is. So I'm going to show you where e is on the calculator real quick. So let me go to my calculator. So if you look on the right side, right above that divide symbol, Right above divide, you see a blue E. That's the E there. Now, if your E has an exponent, you can use the one over here on the left side of the 4 above the LN button. You see an E with an X. If you punch that one, it lets you punch in an exponent with us. So first, I'm just going to show you what E value is. Because remember, pi is like 3.14, blah, blah, blah. Well, E, if you punch second divide and pull in E and hit enter, E is approximately 2.71828, and that number keeps going on forever and ever, okay? So in this chapter, we'll be playing with that E a little bit, okay? So let me show you what they want us to do first. Now, this E, like I said, is what we call Euler's number. So if you remember, they found pi. They figured out what pi was to deal with circles. Well, this Euler's number, E, they came up with it to help them with interest type problems. So we're not going to get too deep into it. We're just going to sort of play with it a second. See, on my first example doing with this E, they want us to use a calculator to approximate the exponential expression to 4 decimal places. So my number one has E to the 6th. And y'all, these curvy parentheses means we're approximating it. It means we're rounding it off, okay? It's not an exact answer because this thing goes on forever and ever, just like pi. It never stops going. So they just want us to round it to 4 decimal places. So that means 4 numbers after the decimal. So for E to the 6th, I'm going to go to my calculator. And I'm going to use the E above the LN. So I'm going to hit second LN. That pulls up my E, and my exponent was a 6. So now I'm going to hit enter and see what it gives me. Now remember, they want me to round this 4 decimal places after the decimal. So I'm going to have the 403 point. So the 4th number is a 7. So if you're rounding it 4 places, you got to look at the 5th number. If the 5th number is 5 or greater, you're going to round the 4th number up. If the 5th number is 0 through 4, you're going to leave the 4th number alone. So our 5th number is a 9, which is 5 or greater. So that means the 4th number, which is a 7, will round up to a 8. So that I get 403.4288. Okay. Now I'll show y'all a trick on this calculator. If you're weak at rounding stuff up, I can hit mode and arrow down to where it says float. Float means it'll put as many decimals as it can. But if you arrow over to 4 and hit enter, now 4 is highlighted on my calculator. That means it'll round all my answers off to 4 decimal places. So y'all watch when I hit clear, and I'm going to hit enter on that answer. And there's that 403.4288. 8. Okay. So if you want the calculator to help you, just go to mode and go down where it was on float and put it on 4. Now what I'm going to do is just put mine back on float, and then I'm going to quit the screen. Right, y'all, so let's try number 2 here. They got e to the negative 3.43. All right, so let's go back to that calculator, because I will say this chapter we're in is going to be calculator heavy. All right, so I'm going to hit second LN to get the E with the X. And I'm going to put in a negative 3.43. I'm going to hit enter. All right, y'all, so we need to go 4 decimal places. So that's going to be a 0.03, 2. So I'm looking at the 4th digit, which is a 3. It's got an 8 after it. So 8 is 5 or greater. So that 3 will round up to a 4. So we'll have 0.0324. All right, so no, that's what the first 2 problems wanted. Well, just so y'all can get acquainted with the E, okay? All right, so next, we'll start looking at the graphs. So they want us to graph the equation and then choose the correct graph. So this would be like number 3 here. Y equals 6 to the X. Now I'm going to do this by hand. Now we know what this is going to look like, remember? Since that A is greater than 1, remember this graph should go uphill left to right. That'd be an example of this one when I was showing you a while ago. Y'all, I probably won't do too many numbers on here because these numbers get big quick, okay? So let me start with 0. If I put a 0 in for the X, 6 to the 0 is going to give you 1. Any number to the 0 power equals 1. So I'm just going to start with 5 on here. So I'm at 0, 1, crossing that y-axis. So let me put a 1 in there. If I put a 1 in for the exponent, 6 to the first power is 6. So anything to the first power is itself. So I'm going to go up here a little bit. So when x is 1, my y value is 6. So y'all, let me try 2 for my x. If I put a 2 in for that x, I get 6 squared. Well, y'all, 6 squared is pretty big because 6 times 6 gives me 36. So when my x is 2, my y value is way up here somewhere at 36. So notice how it's doing. Remember, this graph will come in. It's going to cross at 1, and then it's shortish. It's more curvy. But it's just going to shoot up towards infinity, okay?
You can graph that one on the calculator though.
Oh, you can graph it on there. Let me show you. So let's go to y equals. We got what? 6 to the x. So do 6 exponent and then put in your x. So watch the graph. See, all you're going to see is, remember, this graph is only going 10 by 10, but you can see how steep that slope is. But if you look at the table by hitting second graph, look on the left side, that's why it's trying to get closer to the 0 on the left side. But look at these numbers on the right side. When x is 0, you get 1, like we said. When x is 1, you got 6. When x is 2, you're already at 36. And y'all, when you're at 3, look at that. Your y value is 216. Look how quick this thing is approaching those big numbers. And let me go down here and just show you. At 4, you're at 1200. Look how it's increasing. When x is 6, you're already at 46,000 on your y value. So that's how fast that these exponential graphs increase, okay?
Mine came all the way in from the left side. My graph did.
Uh-huh.
I was able to see it, yeah, like full. I didn't change anything. It just kind of does it on its own.
Okay. Yeah, you probably got it on like a Zoom Fit or something. All righty, try another one of those, y'all. Let's try our number 4 here. And it's just y equals 2 to the x. So y'all, it's going to be pretty much the same. I'm going to start with 0. If I put a 0 in there, 2 to the 0 is going to give you 1. So I'm still crossing here at 0, 1. If I put a 1 in there, 2 to the first is 2. So at 1, I'm at 2. So notice this smaller number is not going to quite be as steep as quick, but it'll get there. If I put a 2 in there, 2 times 2 is 4. So at 2, I'm going up to 4. This is sort of what COVID was doing. It was doubling every so often. Now a 3 in here, 2 to the third, 2 times 2 times 2 is 8. So at 3, I'm already up here at 8. But y'all, you can see it's coming in. Goes through 0, 1. And it starts increasing. Not as steep as the 6 did, but it's still increasing. So I'll show you that on your calculator too. So let's just change that 6 to a 2. And hit graph. So see, it's a little bit wider because it's not quite increasing as fast and steep as that 6 did. Now, if you remember, I said if it was a fraction, if the a was less than 1. So let's try this one. Graph y equals 1/5 to the x. So if x is 0, anything to the 0 is still going to equal 1. So at 0, you're still at 1. When I put a 1 in there, 1/5 to the first power is 1/5. So y'all, instead of going up, this thing is starting to come downhill to the right. If you put a 2 in there, 1/5 squared would be 1/5 times 1/5, which will be 1/25. So look, it's trying to get down to that x-axis. It'll never reach it, but it keeps trying to get closer and closer. Next, I would have 1/125, which is even closer. So let me show you the left side of this. What if this x was a -1 here? We all watch this. If you go to your calculator and put in 1 divided by 5 and raise that to the negative first power, watch what it does. It gives me 5. If you'd have put in a -2 for that, 1 divided by 5, and if you put in an exponent of -2, it's going to give me 25. So let's look at my paper again. So at -1, you were up here at 5. So see, this left side is what's at -2. You're way up here at +25. So you're seeing how the graph is going to come in, cross the x-axis. So y'all, do y'all know how if I put a -1 in there, how it's giving me that 5? So let me show you a little trick on this, how you figure these numbers out here. When you got negative exponents, we don't like negative exponents, so we make them positive. So to make an exponent positive when you got a fraction, you flip the fraction and make the exponent positive. So 1/5 to the negative first. First thing to do, make that exponent positive by flipping the fraction. It now becomes a +1. And 5 divided by 1 is 5. To the first power is a 5. Yeah, so we'll use the calculator for this whole lesson, and we'll use the calculator for pretty much a lot of stuff in this whole chapter. Now let me show you how I put a -2 in for the x, how this one gave me 25. So remember, the first thing I'm gonna do, make the exponent positive by flipping the fraction. And y'all, 5 divided by 1 is 5. 5 squared is 25. So remember, negative exponents, you flip it, change the sign of that exponent. But y'all, let's go to the calculator on this. Go to y equals. I had a 1/5 here. So I'm going to do alpha y equals and hit enter for my fraction. I'm going to do 1 on top, 5 on bottom. I'm going to delete that 2. All right, so now let me put in my x. So I got 1/5 to the x. Let me graph that. And there you go. It's coming down from the left and trying to get on that x-axis. All righty, y'all. Now, those first 4 or so, you're just picking one of the 4 pictures they had on the graphs. So now we're going to get into transformations. So this is where we moved the graphs up, down, left, right. We flipped them over to x-axis before. So we got a few transformations we're going to do with these exponentials. First one is a vertical shift. And y'all, the vertical shift is the same as it was in 7.2. You'll have y equals a to the x plus b. Remember, when I added a number at the end or subtracted a number at the end, it moved me up or down. So if b is positive, then it's going to move me up. Same thing as it was in 7.2. If the number we added at the end was positive, it went up. If the b is negative, then that graph is going to go down. So that was our vertical shift, and it pretty much was the same as it was in 7.2. Horizontal shift. So that's going left to right. So to move my graph left to right, I'm going to have y equals a to the x plus c. So we're attacking that x with our c this time. Just like in 7.2, if the x was in parentheses and we attacked it. If that c is positive, and y'all, this is the same as it was in 7.2 when you attack the x. If that c is positive, it's actually going to move my graph to the left. And if c is negative, it's going to move my graph to the right. So the same thing as it was in 7.2, when I attacked the x into parentheses and I added a number, it moved me left. If I subtracted that number, it moved me to the right. I can still reflect it over the x-axis. And y'all remember, to reflect over the x-axis, I'm going to have y equals negative a to the x. So remember, if I put a negative in front of my function, it flips it over the x-axis. So y'all, the new one will be reflect over the y-axis. So to reflect it over the y-axis, I make the exponent negative. So if my exponent is negative, it's going to reflect me over the y-axis. If I put the negative in front of the function, it's going to reflect me over the x-axis. So remember these moves because we're about to play with these in MathLab, okay?
Are we still using the parabola for the graph?
Not on these ones. On these ones, so for MathLab on these, let me show you what we're going to do. So MathLab, the first thing we're going to do, we're going to choose what they call the exponential tool. So we're going to use the exponential tool, then click anywhere on the graph. Once you click on the graph, it's going to open up the box. So remember, you're going to have that little box open up. And it's going to have the vertical, the horizontal, reflect over to X, reflect over to Y, and all that fun stuff, okay? But y'all, the main thing down here in the left corner, it's going to say base. Now, the base by default is going to have that little E in there. So we need to change the base to whatever number ours has in the function. So you got to remember to change the base down here. So y'all, let me go to one of these and I'll show you what we got going on. I'm going to actually go to MathLab here. And let me see, I think these are starting at 5, maybe 6. All right, so it's starting at 6. So they want me to sketch the graph and check the graph with a graphing calculator. But before doing that, they want to describe how the graph can be obtained from one of the graphs of a basic exponential function. So they're attacking that X by subtracting 3. That's going to move me left or right. So since they're subtracting 3, it's going to move me to the right 3 units. So let's see which answer has to the right. So y'all, that would be A. Now, it says start with the graph of Y equals blank to the X. My base is a 2, so I would put a 2 there. And then we're going to shift it to the right 3 units. So you'll check this answer when you put it in. And then it's going to say, hey, click to enlarge graph. So we want the exponential tool. That's on the second row in the middle, sort of right by that paint can. So click the exponential tool, click anywhere on the graph, and it's going to draw the basic graph. So we got to come down here and figure out what we did. So we said we went 3 units right. So we're going to take that horizontal shift and move that to +3. Now remember, down in the bottom left corner, it says base. It's got the E in there. I need to change that to match my 2. If you don't change the base, although the graphs look similar, it will mark it wrong, okay? So you got to change that base. All right, so only had the one move, moving it to the right. So we would save that and then check our answer. So let's see what this one does. So this one looks like we're going to actually graph it first. So I'm going to click to enlarge the graph. Now notice, it's got a +3 at the end of this. So that +3 is either going to move me up or down. Since it's positive, it's going to move me up. So we click it. We're going to get our exponential tool. Click on the graph anywhere. So we said it went up 3. So I'm going to take my vertical shift and move it to a +3. Now remember, I got to come down here to my base and change it from an E to a 6. So I had a base of 6. That +3 moved me up 3. So we got that in there. We're going to save it. So see how it actually moves the graph up on the picture? All right, then we check that. So the graph of f of x equals 6x plus 3 is the basic exponential graph. Y equals 6 to the x. Remember, the x has to look like an exponent. So you want the 4th choice on here. And then it's going to say, we went up 3 units. So we would pick the last answer, shift it up 3 units. So you know if you got the graph right, you're going to get this part right because it's doing the same thing you did on the graph, okay? So check that answer. All right, y'all. So the last one of those, let's see what you want in the first blank. Start with the graph of y equals blank to the x. What am I putting there?
2.
All right. Then it says shift it blank 4 units. So that 4 is being added to the x. So what's that 4 doing to my graph?
Goes left.
Oh, good. You're on the ball today. And then shift it blank 2 units.
Down.
Down. So y'all, once y'all put that in, you're going to check that. And then we're going to graph this thing. So let's see. We're going to grab our exponential and just click anywhere on the graph. All right, so you said you went left 4 units. So that would be horizontal 4 to the left. I'm going to go to -4. All righty, and then we went down. I can't see it. Was it 2? We went down. So vertical will go to -2. And then remember, I got to do one more thing, right?
Get a base of 2.
I got to put that base of 2 in there. Good job. All right, so once I do that, I can actually save it and check my answer. All right, so we'll play with that in a second. So there's only 3 of those, okay, y'all? So are y'all good on those 3?
Yes.
All righty, so let me go back to my paper then. And we're going to play with an exponential type function. So this formula I'm about to show you, A of t. If I was to invest money, this would show me how much or the amount of money I would have in my account at any time t. So let me write the formula and then we'll go through all the pieces on this. So the formula A of t equals P times 1 plus R divided by N, all raised to the N times T. Right, so this is an investment type problem. If you were to invest money in a bank, so let me show you what everything is. A of t is the amount in the account. So the amount in the account at any time t. And t usually is going to go by years, okay? So it's the amount in the account at any time t. P. Well, y'all, P pretty much stands for what it means. P stands for what we call the principal balance. And basically, your principal balance is your starting amount. So if I was going to invest 5,000, 5,000 would be my starting amount or my principal balance, okay? The R up here, y'all, that is your interest rate. Now, the thing about the interest rate, when you put it in this formula, it's got to be in decimal form. Okay, so P was my principal balance. R was my interest rate. N. N is what we call the number of compounds per year. So it's the number of compounds per year. What that means, how many times a year are they figuring out the interest on this? If it's yearly, it'd be once. Semi-annually would be twice. What else we got? Monthly. Monthly would be 12 times a year. Quarterly would be 4 times a year. Daily, what's daily? Like 365 times a year. So that's how many times they're going to attack that with the interest, okay? And y'all guess what T is? T is the time, and that's going to be in years. Okay? So that's what all my little symbols are standing for: principal, interest rate, number of compounds, time in years. Now, y'all, let me just play with y'all a second. If I had something like 5%, what would 5% be in decimal form?
0.05.
0.05. Good job. So basically, you just move the decimal left twice and get rid of that percent, okay? Yeah, and then we'll play with some of these in a little bit. So that's the formula we're going to play with. So y'all, here we go. Suppose $67,000 is invested at 4.5% interest, compounded quarterly. So this will have an A and a B. So let's play with A first. A, they want us to find the function for the amount to which the investment grows after T years. So basically, they want the formula that I'm going to use to figure out what they're going to ask me in question B on this thing, okay? Now, MathLab will have the A of T here. We just got to put out everything else on this formula. So let's figure this out. What is RP?
67,000.
So I'm going to bring down my 67,000. Then we have parentheses 1 plus R. So what we got to figure out, my R is 4.5%. So I'm going to change the half into a decimal. So that's going to be 4.5%. Okay, so just make that half a 0.5. If it's 1/4, I'd put 0.25 and so on, okay? Now, 4.5%, what is that in decimal form?
.045.
0.045. So that's going to go in here for the R, 0.045. 4, 5. N is next. That goes on the bottom. Well, my N is the number of compounds. Well, they said it's quarterly. So how many would that be?
4.
Yeah, how many quarters are in a year? That'd be 4. And then you're going to close that. And then the N happens up here also. So that'll be 4 times T. Now, MathLab don't want it this way. MathLab wants us to simplify this stuff inside the parentheses. So I'm going to bring down to 67,000. What we got to do is figure out what this stuff in the parentheses is going to equal. So y'all, I'm going to go to my calculator. And I'm going to clear that out. And I'm just going to see what that equals. 1 plus 0.045 divided by 4. That's going to equal 1.01125. So that is what MathLab is going to want in the parentheses. And then outside I got my 4T. Because MathLab always wants you to simplify the parentheses. I can't go no further because I don't know what the T is. So I can't hit the exponent to that. So this is what MathLab is going to want, okay? It wants you to simplify the parentheses. Now check this out. They want to know, they want me to find the amount of money in the account at T equals 0, 3, 5, and 10 years. And y'all, in the answers, it says round to the nearest dollar. So round to the nearest dollar. All right, so let's start with T equals 0. Now, I'm going to show you 2 ways I can do this. The first way, I can put this on the calculator and punch in each one of these one at a time. So let me go to my calculator. So my formula was 67,000. Then I had parentheses. 1.01125. Close parentheses. My exponent was 4 times T. Well, that'd be 4 times 0. Well, y'all, if 0 years have passed and I started with $67,000, what better be in that account? $67,000. Right, if I'm investing $67,000 and no time has passed yet, then I need $67,000 in the bank. So then they said, what about when T equals 3? Well, when T equals 3, I'm going to have the same formula. 67,000 parentheses 1.01125 close parentheses. My exponent this time will be 4 times 3. And y'all remember this. This is an investment type problem. We better have more than 67,000 in this bank, right? So when we hit enter, Now remember, I'm rounding to the nearest dollar, so that means no decimal places. So that'd be 76,626. The 6 will stay a 6 because the number right after it is only a 1. So that'd be 76,626. And y'all, I would do that for the rest. For the 5 and for the 10. I would keep doing that. But let me show you an easier way. If you want all these values at once, I'm going to go to y equals. And I'm going to put that equation in, 67,000 parentheses 1.01125 close parentheses. My exponent will be 4. Now we can't use a t on this part. We got to use the x. So when you're on the graphing part of it, use an x instead of a t. And y'all, I don't even care about the graph. I want to go to the table. So I'm going to hit second graph and go to the table. So look at that. When that t or x was 0, we had 67,000. Let's go down to 3. When the x or the t was 3, I got 76,626. So y'all look at this. They want next t at 5. So I'm going to go to 5. And at 5, I got 83,800. And then I can scroll down to 10. And at 10, I got 104,813. So if you're sort of lazy like me and you just want the numbers really quick, graph it and use your table for those values, okay? All right, but notice it went up 67,000. After 3 years, it was at 76. After 5 years, it's almost at 84,000. And at 10 years, it's at 104, almost 105,000. So it's almost doubled in just them 10 years, okay? So this stuff's not too bad. You just got to play with that formula. In the main part, it's just getting your stuff plugged into this part right, and then coming up with a formula that you can put in your calculator. All right, y'all, so let me do one more, and then we'll do our break. And this one don't have as many parts. So check this out. On Melissa's 6th birthday, she gets.
Can you see your paper?
Oh my God, I didn't move my camera up. All right, y'all. So on Melissa's 6th birthday, she gets a $2,000 CD that earns 6% interest, compounded quarterly. So then it says, hey, if this CD matures, on her 14th birthday, how much money will be available? So y'all, a CD is what they call it, what, a certificate of deposit. So here's the thing. She's 6th birthday. She got a $2,000 CD. Earned 6% interest, compounded quarterly. And they want to know how much will be in there if it matured on her 14th birthday. So we're going to go figure out. Now remember our formula, A of T equals P times 1 plus R divided by N, all raised to the N times T. But now we're actually looking for the amount. So the first question, what is my principal balance?
$2,000.
All right, then we got 1 plus R. We got 6%. So y'all turn that into a decimal. And that'd be what, a 0.06. So we got 0.06. My N, my number of compounds, is quaternary again, so that's going to be 4. So then I put my 4 out here. So the question of the day, what is my T? How
Is
many?
it her birthday?
Say again?
Her birthday, like on her 14th birthday?
So now to figure out the time that passed, take that 14th birthday minus her 6th birthday. So from the time she was 6 until she hit her 14th birthday, that'd be, what is that? 14 minus 6. We should get what, 8 on that. So we're going to have to multiply this 4 times 8. So that really means we're finding A of 8 years. Now, check out this one. They want me to round to the nearest cent. So when they say round to the nearest cent, they want 2 decimal places. Sort of like 10 cents, 5 cents, 25 cents, something like that, okay? Now, 8 years have passed, so I'm expecting a little bit more than 2,000 in this account, okay? Anything less means we done something wrong. So y'all, we're gonna go plug this on our calculator. And I probably won't graph this one because it's only got one value it wants. So I'm just gonna plug it in. We got 2,000 was our principal. Whoops. So 2,000. And then I'm going to go 1 plus 0.06 divided by 4. I'm going to close my parentheses. And then my exponent was 4 times. Oh, y'all, how many years did we say?
8.
8 years. Okay. All right, y'all. So remember, round it to the nearest cents, 2 decimal places. So we got 3,220 for sure. Point. So what are y'all putting for the? Are y'all going to leave that a 6.4 or make that a 6.5?
6.4.
Well, look for that number after.
6.5.
There you go, 6.5. So you have to look at the 8. Since that 8 is 5 or greater, you got to turn that 4 into a 5, okay? But y'all remember, if you wanted to hit mode and go down here to float, since we're going 2 decimal places, if you'll click enter on 2 and then clear that screen, now watch when I hit enter, it'll give me my 65, okay? But I always change that back because I don't want it left there. So I'm going to go back to 9 now and put it back on float. But yeah, you can use them numbers like 4 decimal places, 2 decimal places, and so on, okay? All right, y'all. So we're going to have a break. And when we come back, we're going to learn about logarithms. So is that a new one on you?
It is for me.
All righty, so we're about to learn about logarithms. So y'all take 10 and That'll get us here about what, 10 or 11 after, okay?
Thank you.
All right, y'all. So 9.4 deals with logarithmic functions. So let's figure out what a logarithm is. So y'all, in the long run, a logarithm, it finds the exponent that the base was raised to get the result. So let me show you how that's going to look. I'm going to have a logarithm A of B equals, say, X. This little A right here is what we call the base. It's a number that was being raised to the exponent. The B here, that's the result. And the X is actually the exponent. Okay, so when you punch in a log base, your base and your result, when you punch that in your calculator, it'll give us the exponent that it was raised to. So let me give you some examples of this. Say I had a log base 2 with a result of 8. So what I'm actually wanting on this question is if I started with a base of 2, so I started with a base of 2, I don't know the exponent yet, but that has to equal that result of an 8. So y'all, what exponent would I raise this 2 to get me an 8?
Is it 4?
4.
So y'all went 1 too many. So think about
3.
this. So 2 times 2 is 4. 4 times 2 is 8.
8. Okay.
So we did that 3 times. So the logarithm base 2 of an 8 would be a 3. So to check that, I would put a 2 to the 3rd power. And y'all, 2 to the 3rd power is definitely 8 for us, okay? Let's try another one. How about a log base 5 of 25? What exponent would I raise this 5 to make it a 25? So 5, the sum exponent has to equal 25. What y'all putting?
2.
It is
4.
definitely a 2. Because 5 times 5, 2 times is definitely 25. So that's what this lingo means, okay? So one more and then we'll play with stuff. What if I had a logarithm base 3 of 27? So that'd be 3, the sum exponent equals 27.
9.
3.
Okay, I'm going to go with the 3 because remember, 3 times 3 is 9 times 3 is 27. So remember,
These are going to be so hard like that.
well, here's the thing. Remember, you're not multiplying the base times the exponent to get this number. You're multiplying this 3 times itself ever how many times to get that 27. So you got to remember, exponents are just shorthand for multiplication. So you always want to start with the base and just start multiplying it out until you can get that result, okay? All right, one more to get y'all good. What if I had a log base 7 of 49? How many times you gonna multiply that 7 times itself to get me a 49?
2.
2 times, there you go. Now y'all watch this. We got our calculators, so I'm gonna share my calculator real quick. So let me clear this off and clear that. So to get this, now on the front, you got a log, but that log is only for log base 10. So if there's no number by the log, it's automatically a 10. But ours have got different bases because I was doing a log base 2 and all that. So to get to those, you're going to hit math, and then you arrow down until you find log base. When you find log base, you're going to hit enter. So remember, my first one was log base 2. So I'm going to put in my 2. My result was a 8. So now I got a log base 2 of 8, like my first problem. When I hit enter, remember, we got a 3 on that, okay? So if I want to do the one I had, log base 3 of 27, I would hit math, arrow down to my log base, hit enter. I would put in my 3 for my base, and then in for my result would be the 27. And remember, we said that was 3. So I'll pretty much use, and they're wanting you to get good at this on your calculators, okay? Now, before we get into playing with the logarithm stuff, I just wanted to show y'all what a log was. But y'all, these first few examples, they just want you to graph them and pick a graph. So we're going to graph y equals log base 3 of an x. So we're going to go to our calculator. We're going to go to y equals and clear that out. So remember, to get that log base 3 of x, I got to hit math and arrow down to log base, hit enter. Our base was a 3, and then I put in my x. All right, y'all, we just want to graph this. So watch this. It's just a little uphill graph going to the right. And they'll have 4 pictures on that. You just pick a picture and move on, okay? So let me see what they had next for us. So the next one, they want me to do f of x equals log of x. Now remember, since this one doesn't have a base here, the base would automatically be a 10, okay? But we don't have to use the same log base that I used on the first 2 problems, because if you'll go to the calculator and go to y equals, I'm going to clear that one out. Do you see the log over here by the 7? If you punch that log, that is a log base 10 automatically, no matter what. Any other base, you got to go through the math and get the log base, okay? So this one, I'll just put in my X. So it looks like they had log base of X. We would hit graph. And notice it still sort of goes uphill to the right. Y'all, the thing about these graphs, they cannot be on the left side of the y-axis, okay? Now, the third one they wanted us to graph. F of X equals the ln of X. So y'all, the ln, it's a log base E. And remember, the log up here is a log base 10. So if it's just a log, it's base 10. If it's a ln, we call that the natural log. And it's a log with that little base E on it, okay? But y'all, we got an ln button on the calculator, so we can graph this with it. So let me go to my calculator, go to y equals and clear that. Under the log button by the 4 is the ln. So hit ln and put in your X. And then hit graph. And notice it goes uphill to the right. All these graphs, if you notice, look basically the same on this, okay? All right, y'all, so any questions on that graph, and you're just going to plug it in there, hit graph, and be done with them, okay? So now, we're actually going to play with what we call find the logarithm. And these will start at number 4. So y'all, I'm going to find the log base 6 of 1,296. So how many times do I got to multiply a 6 times itself to get 1,296? Well, let's go find out. So I'm going to quit that screen. So remember, to get a log base 6, I got to hit math and arrow down to log base. Hit enter. I'm going to put in my 6 for the base. Whoops. Let me go back and delete that one. 6 for my base, and then 1,296 was that result. So y'all, let's see what that is. That's going to give us 4 times. So that means 6 times 6 is 36. Times 6 is like 236, I think. Might be 256, can't remember. And then times 6 will be 1,296. All right, y'all, log base 8 of 512. So do y'all want to punch that in and see what y'all get? Any of y'all got a calculator?
3. Yeah, 3.
Yeah, because 8 times 8 is 64. 64 times 8 is 512. How about a log base 10 of 1,000? Now remember, they didn't have to put the 10 here. If they'd have put log of 1,000, it would have meant the same thing, okay?
Mine shows 3.
3. 10 times 10 is 100. 100 times 10 is 1,000. So remember, that's all we're doing. We're just looking at how many times does this base got to multiply to get this 1,000, okay? Watch this one, y'all. Log base 3 of 1 over 27.
Does -3 make sense?
It is definitely a -3. Anytime you got a fraction like this, you're going to end up with a negative exponent, okay? But y'all ought to done that the same thing. So let me show y'all for y'all that didn't get it on the calculator yet. I would go to my math and go down to log base. Hit enter. Put in my 3. And then arrow right and do 1 divided by 27. Or you can use the alpha y equals and make it look like a fraction either way. And oh, there you go. There's that -3 on that, okay? How about this one? ln of 1 divided by e. So y'all, the ln we can do on the very front. We got an ln button by the 4, so we would hit ln and then put in a 1 divided by e. Now remember, this is a fraction, so I'm expecting a negative answer. Now to get the e, I'm just going to hit second and then divide to get that e, and then close my parentheses. Y'all, let's see.
-1.
-1. Good job. All right, how about this? Log of 10. Now remember, there's not a base here, so it's automatically a 10. But y'all think about this. What exponent would I raise 10 to make it a 10?
1.
Definitely a 1. Actually, there's a little property on this that says the log of any base that matches any result equals 1. So the log base smiley face with a resultant smiley face equals 1, okay? So if those two match, it's always going to equal 1 for us. How about this? Log base 3 of 3 to the 4th. So think about it. What exponent would I raise 3 to turn it into a 3 to the 4th? So y'all, let's go play with that and see. I'm going to go to my log base, arrow down to log base. I'm going to hit enter. I'm going to put in my 3 for my base. That result was a 3 to the 4th power.
Is it a 4?
It is a 4. And y'all, that makes sense. Think about it. If these base matches the base of the result, then the answer has to be the exponent 4. So you would raise 3 to the 4th power to make it a 3 to the 4th power, okay? All right, y'all, log base 5 of the 7th root of a 5. So now we got to learn how to put in these radicals. So watch what I do on my calculator. So let me clear everything off real quick. So I'm going to put in the log base first. So I'm going to go to math, arrow down to my log base. Hit enter. My base was a 5. Now I'm going to arrow over to the result. The result was a 7th root of a 5. So watch this. To get that radical, I'm going to go to math. And do y'all see number 5 here? Number 5 has an X in front of the radical. That's the one you're going to choose to put in your 7th root. So hit enter on number 5. So where it's blinking, I'm going to put the 7. And then I'm going to arrow underneath and put my 5. So to get them radicals, I use that button, okay? So let's see what log base 5 of the 7th root of a 5 gives me. Now remember, I don't want a decimal, so I'm going to hit math and hit enter twice to turn it back into a fraction. And y'all, I get a 1/7. All right, y'all, let's see what was next. So basically, if this base matches what's under that radical, then the answer will always be 1 divided by whatever this number is in the index. All right, y'all, this one has log of 10 to the -4. Now remember, this one don't have a base, so we can use the log on the front of the calculator. But what exponent would I raise that 10 to turn it into a 10 to the -4th? So what y'all getting?
-4.
-4, good job. And it's like this number 10 here, right? So remember, I got a 10 here that ain't shown, it's a 10. So the 10 matches the result base 10, just like this 3 matches the result base 3. So the answer up here was the exponent 4. The exponent here of -4 is that answer. Log base 64 of a 4. So y'all push that in and see what you get. So we're going to go to log base.
Is it 1/3?
Oh, good job, because you got a 64 here. You got a 4 there. So anytime that result is smaller than your base, you're going to get a decimal, and then we're going to turn that back into a fraction. And you do get a 1/3. All right, y'all, log base 33 of a 1. So what exponent would you have to put behind that 33 to turn that thing into a 1?
Zero.
It's got to be a 0. So check this out. Another little property. The log, no matter what that base is, if that result is a 1, then that's automatically going to be an exponent of 0. And y'all watch this on your calculator. Say I had 5 and I raised it to the 0 power. Look at that, it's going to give me a 1. What if I had 9, raised it to the 0 power? It's going to give me a 1. So no matter what the number, if you raise it to the 0 power, it will equal a 1. So that's why if you got a logarithm, no matter what this base is, if that results a 1, then it has to be because the exponent was a 0. All right, y'all, 15 was an ln of e to the -1. Now remember, the ln is really a log base e. So I got the base of my log matches the base of my result to an exponent. What answer will I get?
-1.
-1. Because y'all, we got the ln button right here. Now to use the e with the exponent, I would actually hit second ln to get that e, put in my -1, hit enter, and we definitely get a -1. All right, y'all, 16 ln of the 9th root of an e. This one's going to be really similar to number 11, except they're using an ln. So remember, that's really a log base e. So the e matches what's under that radical. So let's see what we get on that. So y'all remember on that one, I would hit my ln button. To get that radical with the 9, I would hit math, arrow down to number 5, and hit enter. I would put my 9 in the notch.
19.
And then underneath, I'll put that E. Good job. And once I turn that into, I should get what you just said, a 1/9. All right, y'all. So then we're going to learn how to convert from logarithmic to exponential. So converting between logarithmic and exponential. Exponential means it's going to be wrote with exponents. So remember, exponential would be something like y equals a to the x. Logarithmic would be using the logs. Log base a of y equals x. Okay, so notice the base of the exponential raised to an exponent equals y. Over here, the base of a with the result of y equals the exponent. So these convert between each other. So let me show you what I got first. On these examples, they want us to convert to logarithmic. Now, these will be the kind of things we're learning this so that when we solve equations, we can go back and forth. So we'll have to solve equations. I think that'll hit us Friday, okay? Now, let me show you what they're giving me. And these will start at 17. They're giving me 10 to the second power equals 100. They're giving me the exponential. I need to write it as a logarithm. So I'm going to bring down my log. So what would the base of my logarithm be? Well, y'all look here. The base is a. In the exponential, the base is the number in front of the exponent. So the base of this logarithm will be the 10. The result goes here, which is what?
2.
Well, remember over here,
It's the 100, isn't it?
it's the 100. There you go. And that equals the exponent, which was a
2.
2. There you go. All right, y'all. So that's all we're doing on these. So how about this one? 1024 to the 1/5 equals 4. So I'm gonna bring down my log. So what is the base of this logarithm? In the base,
1024.
the 1024. The result goes next, which is the, so see, the y is the result. Well, the y was the result of the other one, so the result is the 4. And then what's the exponent that equals?
1/5.
1/5. So you got to remember this. This whole logarithm, all it's doing is finding the exponent. So the exponent is always the right side when you got the logs, okay? All right, so let's see what we got here. E to the -2 equals m. All right, so I'm gonna bring down my log. First, I need my base. All right, y'all. So remember, my A is the same as
The E.
It's the E. There you go. The result is the m. That's going to go next. And that equals that exponent, which was a -2. Now, there's another way I could rewrite this, right? Instead of log base E, couldn't I do this? Couldn't I do a ln of m equals -2? Because remember, the ln stands for the log base E, okay? Now, I'm sure MATLAB should take it either way, but if you punch this in and it don't like it, do it this way, okay? All right, y'all, one more of these. P to the K equals 121. Now, y'all, let me tell y'all something about this right here. I get more mistakes on MATLAB because people put that as an IN. That is not an IN. That is a little L and an N. When you punch it in MATLAB right, it'll make it dark and bold, okay? If you put an IN, it's going to mark it wrong every time. That's a LN. All right, let's do this one. We're going to write a log. I need my base.
Base is P.
All righty. The result is the 121, and that equals my exponent of a K. So remember, converting to logarithmic, use this right here. I use that to go both ways. The A for the log is the same as the A, which is the base of the exponent. The result of the log is the same as the result of the exponential. And then the X, which is the exponent, is the same as the exponent of the exponential. So y'all, guess what? We're going to go the other way. And we're going to convert to exponential. Now remember those, remember them crossovers here. So we're going to convert to, what did I say, exponential. So number 21 has log base 3 of a 9 equals 2. So if we're going to exponential, I need my base, Well, the base of the exponential is the same as the base of the logarithm. So that would be a 3. So y'all, what am I putting here for my exponent?
2.
All righty. And 3 to the second has to equal R9. And y'all, 3 times 3 does equal 9. So we got it wrote right because it's true, okay? All right, how about this? Log 0.1 equals -1. So what would be my base? And y'all, they don't even have a base row. So it's automatically what?
10.
There you go. The exponent is,
-1.
and y'all, that's going to equal what? 0.1. And y'all, the more y'all play with these, you'll get used to that conversion there. All right, here's another one. ln of 25 equals 3.2189. So no base shown on this ln. So what is my base?
10.
Well, this one's
E.
it's the E. There you go. So remember, the regular log is a base 10. The natural log, the ln, is a base E. My exponent is the 3.2189. That's going to equal that result of a 25. All right, y'all, one more of those. Log base m of a capital R equals a negative z. So once they think you get good on stuff, they throw the alphabet at you. So what I need is my base.
M.
All right, what's going to be your exponent?
-Z.
And that's going to equal that result of a R. Now, y'all be really careful. If they use little m, you got to put a little m. Capital R, you got to use a capital R, and then that little z. They are very picky about capital letters and lowercase letters, okay? All right, y'all. So now basically the rest of this is just getting good on the calculator and rounding out 4 decimal places. So let me do a couple of these. And these will say use the calculator. But we're going to round it 4 decimal places. Sort of like a while ago when we rounded those answers on our E to 4 decimal places. We're still doing that on these. So these started at 25. So y'all, I want the log of 68. And remember, the curvy parentheses means we're approximating it. So I'm just going to go to my calculator. The log is on the very front. Log, put in that 68 and hit enter. I want 4 decimal places. So that's going to be 1.83. Okay, the 5 is in the 4th spot. Are y'all keeping that a 5 or would y'all make that a 6?
Keep it a 5.
Keep it a 5 because it's got a 0 following it. Good job. All righty, so we made that a 5. So let's see, 26 log of 47. So the same thing, y'all. I'm going to go to that calculator. I'm going to hit that log button and I'm going to put in my 47 and enter. All righty, y'all. So I got a 1.6720. Are you keeping that a 0 or would you make that a 1?
Round it to 1.
Round it to 1 because it's got that 9 after it. All right, y'all, log of a negative 77. So I'll let y'all punch that one in for me.
An error message for non-real numbers.
Oh, okay. So if this was a log base 10, technically, there's no exponent that I can raise 10 to make it a negative number, is there? That's why that graph of those logarithms will go. You remember they sort of came up and went across like that. They can't be negative x's. So this x here cannot be negative. There's nothing I can do to a 10 by multiplying, look, 10 times 10. That's going to keep giving me positive numbers as I go. There's no way to turn that 10 into a negative 77. So since it says not a real number type stuff, we say that this does not exist. So if you put a negative number in here, it's going to not exist every time. There's nothing I can do in the real world. Alrighty, y'all. Then they want y'all to play with the LN. LN of 39. Well, we got an LN button on that calculator. So we're going to hit LN, put in our, 39, hit enter. So 3.66. All righty. So I'm looking at that 5. Am I keeping the 5 or is it going up?
Going up.
Going
Going
up.
up 1 because of that 6 behind it. So this will be 6636. Now, y'all remember, if you wanted to, you can change that calculator, float it on a 4. If you put it on 4, it'll round you off 4 decimal places. All right, so 29 is the same thing. So let me go to 30. 30 has an LN of a negative 0.15. What am I getting on that?
An error.
Yeah, it's going to give an error because remember, this is really a log base E. There's nothing I can multiply. I can multiply E as many times as I want. It's never going to turn negative. So this one does not exist. So y'all, the moral of the story, I cannot take a log or a natural log of a negative number, okay? Now these ones, these exercises say use find a log using change of base formula. Now, we're not doing all this because watch what they're giving me. They're giving me log base 5 of a 70. This was old school change of base stuff. We got a log base on our calculator that does this for us. So for these, we're actually going to use our log base on the calculator, okay? So you would pull up your calculator, go to math, arrow down to log base, hit enter. I'll put in my 5 for the base, arrow right, and put in my 70. Now, y'all, before I get the answer, let's think about this. 5 squared is 25. 5 to the third power is 125. So this exponent has to be in between a 2 and a 3 to get a 70. So watch this when I hit enter. All right, so let's round this off. Still doing 4 decimal places. So 2.639. So the question is that staying a 7 or is that turning into a 8?
Stays.
It stays a 7. Good job. So there's a few that are going to say use a change of base, but all we got to do, like I said, is use our log base. So y'all, the very last one on here is a calculator graph. Oh, let me see. Let me flip over. So if you notice, this section 9.4 is nothing but getting you good at that calculator. So this one wants us to graph, and they want us to use the same graph for both of these. So they want me to do this one. F of x equals 5 to the x. And then they got an f negative 1 of x equals log base 5 of x. So for this one, I'm going to put this one in y1. For this one, I'm going to put it in y2. Do y'all remember what that f negative 1 of x meant? So y'all did that way back in like 9.2, I think it was. But remember that f negative 1 of x, that means it's the inverse function, remember? When I had y'all replace f of x with y, switched out the x and y, remember? Then we solved it for the new y. And when we were done, we replaced the y with the f inverse notation. But y'all, that ain't no, we don't have to worry about all that. We just got to graph these two and pick out one of the pictures. So I'm going to go to my calculator, go to y equals and clear this out. So in y1, I would put my 5 to the x. So 5 exponent x. Now we know that that graph is going to go uphill, left to right, because that 5 is greater than 1. Now the other one wanted me to do log base 5 of x. So I'm going to hit math, go down and get my log base, hit enter, put in my 5 for the base, and then my x for that result. Now remember, these log graphs, they didn't cross to the left of the y-axis. They just sort of went uphill to the right. So watch as the calculator graphs these two. Now we'll say on MATLAB, they're using the window of 5. So let me change my window and see what happens. We'll make that a -5. Make that a +5. I'm going to arrow down, make that a -5. And then a +5. So they're using 5 on their window so you can see the graphs a little better. So y'all let me hit graph again. So there's the one up, and then the log is the one on the right. So y'all, they'll have 4 pictures. One will look like that, okay? Now remember, to change that window back, all you got to do is hit zoom 6, and it'll put it back on 10 by 10 for you, okay? So now when I look at my window, it's back on my -10 and 10. So y'all, here's the thing. 9.3, section 9.3 dealt with exponential. 9.4 deals with logarithmic. And they are inverses of each other technically, okay? So if you notice, main thing today was getting you good on your calculator. So tomorrow's Thursday. We're only going to do 9.5 tomorrow, and I think it had a little support. And we're going to learn about properties of logarithms. Friday, 9.6, we're going to start solving exponential and logarithmic equations.
That doesn't sound near as fun.
Oh, they're not bad if you learn. So tomorrow's a big day. If you learn those properties tomorrow, Friday will be a breeze, okay? And guess what? Friday will be our last day of anything new. Starting Monday, I'm going to review you for test 4. Tuesday and Wednesday, I'm going to start getting y'all ready for my final exam.
Sounds good.
But my final exam is 25 multiple choice questions. So you don't have to worry about, am I putting this answer in right? Did I put the right X equals or none of that? Multiple choice, A, B, C, D, all the way through, okay?
Bless you.
So y'all play with 9.3 and 9.4 today. Tomorrow we knock out 9.5. So I'm going to quit my recording